Here are the work solutions to the problems for Chapter 3. Firstly, we'll start with the name program. Here is my solution to the name program. I've called it fullname.c. You'll find it in the solutions folder under Chapter 3 on the CD. Okay, let's have a look at what's going on here. Okay, getting down into the main, I've declared 3 variables. One to store the first name, one to store the surname, and one to store the result. I've made a decision that names can be 30 characters long. That is going to be the inherent limitation in my program. So I need obviously 31 characters for each of first name and surname, because I need to store the null. Now here in result I've made that 62. Why 62, you say? Why not just 61? If it's just going to be 30 plus 30 plus the null. Well, it's going to be 30 plus 30 plus a space plus the null. So that's got to be a total of 62. Okay, it is actually possible, some of you may have done it this way, to simply concatenate the surname onto the end of the first name, and you don't need a result variable at all in that case. And that's perfectly fine, I've got no problem with that. But you need to make sure that the first variable, first name variable, is actually of length 62 at that time. So just as long as you've done that, that's no problem. Okay, so we go and have a look at the reading in. It's pretty straightforward, except you recall from our scanf module that I'm going to use this technique for reading in a string, not the %s. Because, well, they might have spaces in their first name. They might have 2 first names. Certainly we could have 30 characters may have a space in it. So we're reading up all characters that are not new lines. And then we use a flush here to get rid of the new line. So don't forget to do that. Other than that, it's very straightforward. Okay, so we read them in, then we concatenate one to the other. And this is how we do it. First we copy the first name into the result. Then we concatenate a space onto the result. Then we concatenate the surname onto the end of the result. So the first is a strcpy, and the second 2 are strcats. Now, some of you may have tried to do this. You may have tried strcat as the very first thing here, to strcat first onto result. That would not work. And you might think to yourself, why not? Seems pretty straightforward. Result doesn't have anything in it, and then you could concatenate the first name onto the end of the result. Surely that would work if result was empty. Well, that would work, except result is not necessarily empty, because if you look here, I have declared it, but I have not initialized it. And if it's not initialized, then it contains what? Is it empty? No, not necessarily. It could contain any random characters, just whatever happened to be in memory at that particular point in time. It's not initialized. Strcat requires the first string to be a legitimate, legal, initialized string of some description, and result would not be at this particular point. That's why you can't use strcat the first time. Okay, so to move on, output the result. Your full name is %s, which comes straight from there, and the length %d comes straight from there. Now that's interesting. We haven't seen that before. We haven't seen the result of a function used inside another function. Some of you will have used a variable called length to store the length, and then just put a reference to length right here. And that's fine, you can do that. This way, you do that without the need for a variable called length, and without the need for an assignment statement that assigns the length into that variable. You can just do it straight in line, right here, inside the printf statement. That is possible. Question is it preferred? Well, that's a matter of style. Some people will say, yes, it is preferred because it's more efficient. And it's not only a smaller program, but it's a faster program. And that's true. And other people will say, no, it's not preferred because you're mixing up your calculations. I would say that this part of the program is the calculation part, and this part of the program is the output phase. And they're saying this legitimately belongs in the calculation phase of the program. And that's a legitimate argument as well. So stylistically, I'd say it's in the wrong place, but for efficiency, it's in the right place. It's completely up to you as to where you decide to put it. Okay, so let's check that it works. Compile it. compiles OK. Run it. Please enter your first name, Mark. Please enter your surname, Virtue. Your full name is Mark Virtue, correct. And it's how many characters? 4 plus 6 plus 1 is 11. Okay, so that's working fine. Let's now have a look at the temperature program. Here's the temperature program. Okay, firstly we've got here a Fahrenheit variable to store the answer. That is going to be a floating point number because I required the output to 2 decimal places. I could have used a float here, but I chose to use a double. Now, remember I challenged you to try and get the program to work, making Celsius an int. How many of you got that to happen? Not many, I'm guessing, unless you've seen this sort of thing before. If you'd made Celsius a double there, it wouldn't have been too difficult at all. Let's have a look at how I've done it. Okay, firstly we get the Celsius value from the keyboard. That's pretty straightforward. %d scanf. Don't forget the little ampersand there just before the Celsius. Okay. Perform the conversion. Fahrenheit equals 32 plus Celsius times 9/5. The formula is quite simple, and we can just write it out like that, and it actually works. The question you're probably asking is, what is this? It's a type name, double, inside brackets, just before the word Celsius. Well, that's called a cast. It's called a cast. It's almost like a conversion. Not this type of conversion, the Celsius to Fahrenheit conversion, but a type conversion, converting an int to a double. Let me explain. Let's take it out just for the moment. I'll get rid of that. Now, this is what a lot of you will have written. Now, if Celsius is an integer, this will just not work. It won't work. It'll work for whole numbers, like if Celsius was 100 degrees, Fahrenheit would be 212. But what if Celsius was 99 degrees? 99 degrees Celsius is 210.2 degrees Fahrenheit. 210.2. But what's going to happen here? Firstly, we're going to have, let's say, 99 in there, and we're going to multiply it by 9. Notice that the multiplication is going to happen before the addition. Multiplications and divisions always happen before addition, so the addition in this line is going to happen last, once all that has been done. Okay, so the first thing we do is we multiply that by 9, and we get 991. Then we divide that by 5, and we get 178. Actually, it's 891, not 991. So the answer to this, well, let's think about it. The answer to that is 891 divided by 5 is actually 178.2. But you remember from before that when you divide numbers, if they're both integers, then you end up with an integer answer, and it's always rounded down. Now this is an integer, 891, and this is an integer, 5. So the result of the division is going to be an integer. It's not going to be 178.2, it's going to be 178. And then we add 32 and we get 210, and 210 gets stored in Fahrenheit. Even though the correct answer is 210.2, we only get 210. So it doesn't even matter, if we're going to do it like that, it doesn't even matter that Fahrenheit is a double, because we're only ever going to store a whole number in it. So we will get 210.00 coming out of our printf at the end. So that's why I put that double in. And this is what it does. It temporarily converts this Celsius from an integer to a double, just for the purposes of this calculation, just for this line. So this Celsius is now a double. Just now it's a double. And down here it's still an integer, but just on this line it's a double. So we take the double and we multiply it by 9 and divide it by 5, so we end up still with a double, because we started with a double. So we end up with 178.2 plus 32, and that's still a double. It's 210.2, and 210.2 gets put in there. That is called a cast. We're going to learn more about casting at a later stage. Okay, let's move along, and we output the result to 2 decimal places. That 0.2 means show me exactly 2 decimal places, and that's pretty much all there is to it. Let's see if that works. Okay, and run. please enter a temperature in degrees Celsius. How about 100? And that's 212 degrees Fahrenheit, 0.00. Correct. Okay, let's try it again, and this time we'll give it the magic 99 degrees Celsius. It's 210.2 degrees Fahrenheit. Excellent, so it's working both ways. Have a little think about that cast, see if you can think of other instances where that might be useful. But we will look at casting in a later chapter. Okay, those are the completed exercises for Chapter 3. Notice they're fully commented. Everything that needs explaining is explained. Actually, they're possibly a little bit too much in the way of comments, because output the result, well, that's clearly what's being output, so we don't really need to be quite that explicit. Okay, that is the end of Chapter 3.